Hi guys, I trust that you're feeling well and awesome. Welcome to this video on grade 11 Euclidean geometry, and in this video we'll be having a look at the proof of the theorem that states that the angle at the center of a circle is twice the angle it subtends at the circumference. In other words, we're trying to prove the theorem that states that the angle at the center is twice the angle at the circumference. So we're trying to prove that angle AOB, this angle, is twice angle ACB, the angle over here. So in other words, we want to prove that the angle at the center is twice the angle at the circumference. So let's get straight into it. The first thing that you would do is you would need to construct a diameter. And if you remember from the first video that we uploaded on the series, we said a diameter is a special type of chord that passes through the center. So the diameter that we're going to construct is CD. And because we are doing a construction, you would remember I said to you in the previous video that we need to have a dotted line. So we are drawing a line from C right through the center of the circle, and we are going to call the next point where the diameter lands, we are going to call this point D. Naturally, that's a terrible D. This would mean that we've got O1 and O2. This will mean we've got C1 and C2. So now we can start with the proof. We can see that O1 is equals to C1 plus angle A. And the reason for this is the exterior angle of a triangle. So the exterior angle of our triangle is equals to the sum of the opposite interior angles. So there we have it. O1 is equals to C1 plus A. The reason is the exterior angle of a triangle is equals to the sum of the opposite interior angles. But what we can do is we can see here that C1 is equals to A. Now, if you look at the triangle that I'm about to highlight, so if we look at triangle AOC, which is this triangle that I am highlighting in green, we could see that this is actually an isosceles triangle. And the reason for this is in the previous video, we spoke about the radii being equal. In other words, we're saying that this line is equals to this line. So this makes it an isosceles triangle. So the reason that we can give for the statement that we have here is that we could say that these are angles opposite equal sides. So therefore, this implies that if I go back to my first equation, where I see A, I can substitute C1. So I could say this is C1 plus C1, and this is actually going to give me 2C1. So in other words, angle O1 is equals to 2C1. When we look at the second triangle, we could see that angle O2 is equals to angle C2 plus angle B for the same reason. The exterior angle of a triangle is equals to the sum of the opposite interior angles. I hope that this makes sense to you guys. So there we have it. The exterior angle of a triangle is equals to the sum of the opposite interior angles. But what we can see here is we can also see that C2 is equals to B. For the same reason, we've got an isosceles triangle, so we could say angles opposite equal sides. And therefore, if I could just scroll down for some room, if I go back to my first equation, I can say that O2 is equals to C2 plus C2, which is just going to give me 2C2. Now, what we can do is we can take the O1 that we have here and the O2 that we have here, and we can add them up. So I can say that O1 plus O2, and this is going to give me, for O1 we said we've got 2C1, for O2 we said we've got 2C2. So O1 plus O2, this is going to give me, if I take out a common factor of 2 here, I'm going to remain with C1 plus C2. Now, if we can navigate back to the diagram, you will see that angle O1 plus O2 is the whole of this angle here, which is angle AOB. So I can say angle AOB is equals to 2, then C1 plus C2 in our diagram is this angle here, which is angle ACB. So I could say this is equals to 2 ACB. there we have it. We have actually proven the theorem which we were required to prove in the first place. Life is great. I hope you guys enjoyed this. I hope this makes sense to you guys, that you understand how to do the proof. If you do enjoy this video, please give us a thumbs up. Please subscribe to the channel. Click on the bell icon so that you will always receive an update every time we upload a new video. As usual, please share the video with others so that everybody can be benefiting from the knowledge that we're learning. Until the next time, ciao.